Okay, so what we're going to do in this video, we talked about the basics of infrared, and we said that certain bonds give you certain peaks, and they're not really peaks at all, they're troughs, and the presence of those will let you know which molecule you've got there. And also, we just remembered that the so-called fingerprint region is from 1500 onwards. It's all that stuff there. That doesn't tell, though, that's unique to the molecule, but that you don't look at that to see which bonds are there, because you can't work it out because it's too complicated. Okay, it's too kind of random. Right, so you're only really looking at half of the spectrum. Right, so let's, I said AQA give us this table here, and some of it is not worth knowing because like these two, CO and CC, they're in the fingerprint region, so we're not going to worry about them. But there's other ones that come up all the time. We need to be able to recognize them, not so much by the number, but by this shape. Now, I think mentioned alcohols already, which is the green one here. Okay, alcohols, it's a giveaway. It's the OH in alcohol, and it's right next to the CH peak, so you get this double peak there. Like that's in that left-hand side of the spectrum. That's an alcohol. That's very easy to spot. Now, of course, not only alcohols have an OH, but carboxylic acids have an OH group as well. So right here, right, that's the carboxylic acid. Now, our carboxylic acid we've got in the yellow color, so it's this yellow one up here. This is our carboxylic acid. If you have a look at the OH, it's a bit, it's shifted a bit to the right of the OH in the alcohol. And can you see what it does is it tends to swallow up that CH peak, so you don't get the double peak. Can you see here? It's very, very broad. That's the first thing. That's a giveaway. Carboxylic acid, it's much broader than the alcohol OH, and it swallows up that CH peak, so you get this funny little shoulder thing on it here, but that's very characteristic. That's a real giveaway for a carboxylic acid. What I should also mention about carboxylic acid, if you suspect it's carboxylic acid, it's usually fairly obvious it is, but of course they also contain the carbonyl group, which I've color-coded in red there. They contain that. Now that is at 1680 to 1750, and this is that's that peak there. It's always very deep and it's quite broad. It's a good chunky peak, you know? Right, it's not like a little insignificant thing. Okay, so that is characteristic of the C double bond O. And fortunately, just below that, we've got butanone. This is this one here. CH2, CH3. That's the spectrum for that. And you can see that the that butanone has got that carboxylic, that's C double carbonyl peak. Again, it's very characteristic. It's deep and it's fairly broad, and it's 1600, and it's exactly just below the one of the carboxylic acid. So that's good. What we've got going on over here, of course, is CH, which is of no use to us at all because everything's got CH. But you can definitely tell there's no H's over there. Well, actual fact, if you just see this little squiggly bit here, I think that is often due to there's a little bit of water in the sample, because water's got OHs, and they tend to the sample should be completely dry because OH and water will absorb infrared. If there's a little tiny bit left in the sample, then you get that peak that's like that over there. Okay, so we've done alcohols, we've done carboxylic acids, and we've done the carbonyls. They're the easiest ones. Now we're going to do this blue one, the CC. Right, that's a bit trickier. Now if you look, it's in a very similar position to the carbonyl. It's about 1600, but it's very easy to spot the difference because look at that peak. It's a puny little insignificance, isn't it? There. It's not like the carbonyl peak, and that's characteristic of the CC. So remember that this is small. It's a much smaller and it's usually not very deep. It's narrow, yeah. And of course, this, you know by now, is the CHs. And again, that's not much use to us because everything's got them. And if you want to know what that is actually hept-1-ene, so 7 carbons with a carboxylic acid, with a carbon-carbon double bond at the end. Right, the final one, which they don't ask very much, is this amines. Okay, now it's in the same kind of region as the OHs. If you look at the values there, which isn't surprising really, because nitrogen and oxygen are quite similar atoms. They're both electronegative, attached to a hydrogen. Okay, so they absorb in the same region, but it is fairly easy to see that looks different. See this? It's not as deep as the alcohol peak. Can you see it there? And quite often it's kind of got that double bit in it. I'm not entirely sure why it's got that, but it does seem to have it. And it's right next door again to the CH. So amine, they have asked a couple of times, but it is a little bit confusing because it's in the same part as the alcohol and the carboxylic acid, but it just looks different. So if you get all those little, if you get all those sorted in your head, the shape of them, and then you don't have to worry so much about your AQA infrared table, wasting time looking at it really, because you can tell without referring to the table. You should be able to just say, right, that is an alcohol, no problem. That is a carboxylic acid. That's a carbonyl, and so on, just by looking at the shape of them. Right. Don't forget about the fingerprint region for infrared as well. And that is about all. Just get them all together for the end. Try and make it a bit bigger so you can see them all together. Okay.